Alright, welcome back to Mr. P Helps with Algebra 2. This is Unit 2, Topic 1, Lesson 1. And I've broken this first lesson into many different parts because a lot of it is stuff that you should have done in Algebra 1. So it's going over a lot of the factoring stuff that you had already covered. But I want to put it on in this video as well, just in case these are things that you need to review. Alright, so starting with greatest common factor. Greatest common factor means the biggest number that both these two terms can both be divided by. So when I look at these two terms, 20 and 8, they can both be divided by 1 and 2 and 4, and 4 being the biggest one of them. So 4x is the GCF because this can be divided by 4x and this can also be divided by 4x. Another way of doing this is to make what's called a factor tree, and that way you can see all the factors, the prime factors of that number. So 20 is the same as 4 times 5. 5 is a prime number, and 4 is 2 times 2, so it's made up of 2 times 2 times 5 is the number 20, and then 8 is 2 times 4, and then 4 is 2 times 2 again. These are all prime. They're prime numbers because they can only be divided by 1 and itself. And then I look to see what's in both columns. So they both have a 2 right here, and they both have another 2, and 2 times 2 is 4. Anytime you multiply all the prime common factors, you're always going to get the GCF. So that's how that works. So that's 4x, and now they both have at least 1x. This has 1x, this has 2x's, so the GCF is 4x. Now 24 and 16 can both be divided by 8. 8 goes into 16 twice, 8 goes into 24 3 times, so the answer is 8p squared. And the reason why it's p squared is because there's 3 p's here and 2 p's here. There's at least 2 p's in both expressions. So there's your answer there. Alright, so getting into factoring. So we're going to be factoring without the GCFs and factoring trinomials without leading coefficients. That's what this video is about. So when you look at this expression, this is a binomial. There's 2 parts. This is a trinomial, 1, 2, 3 parts. This is also a binomial. I'm looking at these 2 parts, and I'm asking myself, what can they both be divided by? They can both be divided by 2. 2x divided by 2 is just x. There's no x's here. 2 divided by 2 is 1. And then x divided by nothing here is still x. 4 divided by 2 is 2. So that's as factored as much as you possibly can. All 3 of these terms can all be divided by 5x. They all have at least 1x, and they all can be divided by 5. 10 divided by 5 is 2. X to the third, remember laws of exponents. Whenever you're dividing things with the same base, you subtract the exponents. 3 minus 1 makes 2. Negative 5 divided by 5 is negative 1. You can put a 1 here. It's not needed. X squared divided by x is just x, because 2 minus 1 is 1. 10 divided by 5 is 2, positive 2, and x divided by x is nothing. Alright, so there we go. And number 3, both these terms can both be divided by 4. Now, since the first term is negative, I'm going to factor out that negative. And they both have at least 2 x's. So this divided by this is x squared, because x squared times x squared is x to the 4th. 24 divided by negative 4 is negative 6. And done. The x's, 2 minus 2 makes no x's. Alright, so now leading coefficients. I'm sorry, no leading coefficients. Factoring without leading coefficients. So first thing is, whenever there's a negative out in front, I'm always going to factor out that negative first. This divided by negative 1 is x squared. This divided is basically just changing everything to the opposite, like such. Alright, so now you multiply a times c. There's no a, it's 1. 1 times 1 is 1. The only factors of 1 and 1 are 1 themselves. So it looks like there is no way to factor here. There's no 2 numbers that are give you a multiply to give you 1 and also add up to negative 5. So this is factored as far as possible. All 3 of these can all be divided by 7. That gives me 7x cubed plus 3x squared minus 1. And both these terms can both be divided by 1 because really there is no GCF greater than 1. Okay, so now getting to the whole idea of factoring without leading coefficients. So it's just like I said before, you multiply a times c, which is 3. I'm going to list all the factors of 3. There's only one. Since it's prime, there's only one set of factors. And I asked myself, which one of these set of factors is also going to add up to the b term? So it has to add up to the b term and multiply to get the c term. So it is 1 and 3, because 1 plus 3 is 4, and 1 times 3 is 3. So there's your 2 factors. It's x plus 1 times x plus 3. Now if you used FOIL, if you multiply everything on the left parenthesis times everything on the right parenthesis, you'll see that you would get the exact same answer. So it's basically like you're doing distributive property backwards. It's kind of what factoring is. It's you're finding what two things multiplied to get that original expression. That's what factoring is. All right, so 1 times 8 is 8. The factors of 8 are 1 times 8 and 2 times 4. This one's going to add up to 6, so those are the two factors. Oh, I needed to factor out the GCF first. I didn't see that they all have an x. And then I've done all my work here because 2 times 4 is 8 and 2 plus 4 is 6. So it's x plus 2 and x plus 4. Alright, so the next one. So 1 times negative 15 is negative 15. Now remember, since this is a negative, that means that one of the two numbers multiplied has to be a negative. Now I'm going to ignore that for the time being. I'm just going to list out the factors of 15, but remember that one of them has to be negative. It has to add up to negative 2. So I see that it's this one. These are 2 apart from each other, and then I ask myself which one has to be the negative one, and it has to be the 5, because since this is negative, the bigger number has to be the negative. Had this been positive, then the 5 would have been positive, the 3 would have been negative. All right, so that's positive 3 times negative 5. And please remember that commutative property of multiplication means that you can switch these two parentheses, you just can't switch the symbols. So as long as you have positive 3 and minus 5 in each of the parentheses, then you should be fine. Alright, I'm going to skip around a little bit. Let's see. So we have, looks like we have questions like this, where you're factoring, but you also notice that there's a GCF. So always look for the GCFs first. Both these terms can both be divided by 2. And then you've got differences of squares. So what I'm doing, this is a perfect square, but it's one's positive, one's negative, which is the reason why the B term disappeared. So this is really x plus 5 times x minus 5. And if you use FOIL, you'll see that these two are the same thing. X times x is x squared, 5 times negative 5 is negative 25. And then when you do the inners and the last, the inners 5 positive 5x, the outers are negative 5x. They cancel each other out. 49 and 9. Okay, so I asked myself what times itself is 49x squared. That's 7x. And what times itself is negative 9, or times its opposite, I should say. So that'd be minus 3 and positive 3. This times this is here, and this times this is here. That's how I did that. Alright, so it looks like we got to the homework for SLT1A. 1 times negative 18 is negative 18. Figure out all the factors of 18, and there they are. And which one of these factors is going to add up to negative 7? That would be this one, 2 and negative 9. So it's x plus 2 and x minus 9 is the answer. This one, so you got negative 14. Which one's going to, this combination is going to add up to negative 5, and the 7 will have to be the negative. So it looks like p plus 2 times p minus 7. This one multiplies to give you 8, and it looks like it's going to be, remember, a negative times a negative is also a positive. So this is negative 8 times negative 1. Negative 8 times negative 1, and negative 8 plus negative 1. So it's n minus 8 and n minus 1. This one, 63. We're looking for factors of 63, so it could be 1 times 63, 3 times 21. What is there else? 7 and 9. That is actually going to be the one I'm looking for. It's going to be negative 7 and negative 9 because they add up to negative 16 and they multiply to give you 63. All right, please give it a like to help you learn something about factoring and factoring out GCFs and when there's no leading coefficients in trinomials. Please look forward. If you already know how to do all these factorings, you can just kind of skip through the next, this first whole SLT is all about factoring, so, and solving. So, okay, don't just skip if you know how to factor, sorry. There's lots of also solving equations using multiple methods like quadratic formula and square root method and completing the square. So these are all things, like I said, you should have done in Algebra 1 though. All right, thanks again for watching. Have a great day.